So if you're ready, then I'm ready.
Always ready.
Cool.
More spaghetti.
Hi everybody, my name is Snoot and I'm one of the community managers here at Coffee Stain Studios, and today we're going to share some insight on some of the systems that we've implemented for Update 4 in order to bring you lights. We're also going to be talking a little bit about the dismantle effect and why we changed that, and a little bit what's coming in the future for that. And we're also going to talk some general performance techniques that we're using to improve performance in the game. And in order to do so, I'm joined by our technical artist Ben, who is going to be sharing some of his insights. So hi Ben!
Hello.
Ben's been featured before in our videos. There's a link in one of the cards here probably with a video with Jace where we showcased some of the water and some of the screen space reflective surfaces, stuff like that. So if you're interested in that, check out that video. But for people who may not know, could you maybe describe a little bit what your role as a technical artist is and what you do?
As a technical artist, you are involved with the art and the technical part of the game. So you're making sure that the art will function, perform, and works with the gameplay elements. So that's it in a nutshell. At Coffee Stain we're a small studio, so there's only one tech artist, which means I'm also involved with performance, some programming tasks too, and just in general making sure that the whole project runs TM.
Nice, cool. All right, so let's dive into it. Let's talk about lights, because that's the main thing that's new in Update 4, and I think one of the hypest things in Update 4. So what was the main issue with implementing lights, and why couldn't we just slap lights into the game with the objects that we had, sort of?
So first case is the infamous object limit. That's one of the reasons, because if you want to build an object, you need to have the object in the world. And we couldn't allow that because that would just add thousands and thousands of objects that would do nothing most of the time. So we had to find a nice solution for that. And second of it, lights are really expensive when they overlap with each other. That's something that we had to find some kind of solution for too. And also to make it nice for multiplayer. Just imagine somebody has the spawn point with 5,000 lights on the hub. The player that joins it can't leave it because their computer will just blow up.
Right.
So for all those things, we had to implement a system to manage lights, and in the end, it was a system to manage objects in general.
Also, to clarify, when we talk about the object limit, we're talking about memory, not well, it's kind of tied to that, but it's not necessarily one-to-one with the amount of objects you place in the world. It's more tied to what the memory footprint of each game object has in the world, rather.
Just to add on that, it is the objects that are in Unreal's garbage collection reflection system.
Right.
Because an object doesn't need to be managed by Unreal, but best cases, it is managed by Unreal.
Right. Cool. So can you just give a quick explanation of how the system for lights works right now?
I have a tiny thing set up to show. So I'm first gonna show the problems with light. I'm totally not using our 1st of April settings. So here we have a beautiful statue, and these are 50 lights overlapping.
Mm-hmm.
So if we show our performance, it's kind of that. We're running at less than 30 FPS, even though not much is going on here.
That looks great.
So yeah, I know. I love the floating peeps. So the first thing, we did an engine upgrade to 25, I think, which gave us a nice feature, which is the rendering thread, the RHI thread, which gives us tons of performance back already. The RHI stands for Rendering Hardware Interface, which is Epic's solution for different rendering APIs. And with the engine upgrade, we are allowed to use a separate thread for this. So partially the work is offloaded to a separate thread instead of only on one thread. So this is acceptable now. So now we can go to stage 2 of the explanation. So the second thing we did with light is normally you would use inverse square fall off, which makes the light look pretty realistic. But the problem is they lose a lot of intensity. So instead of that, we are using no fall off. So the light is the same strength as the beginning as the end, which allows us to have the right distance for the light. So they are way less performance impactful, and they need to overlap way less to get intensity that you would desire.
Right. So they're not like realistic in the sense that most other lighting in the game is, but they kind of need to make sense for the users.
Yes. And here we see the example how it works with a ceiling light. So we slap a cookie cutter on it, call it a light function, and then we cut out a square. So it's technically this light, but we just cut out the other parts.
Right.
And then the biggest issue with the lights is shadows. So let's go to the shadow part. So we have three options. No shadow casting, which looks disappointing. There's absolutely no shadows from anything. The second option is cascaded shadow mapping. This is the classic way of doing it. We have been doing that ever since, I don't know, 2005 probably. It's expensive because just imagine the light being a camera. It looks what is visible and then makes a depth map and projects the shadows on the world that way. So the more objects the light is hitting, the more expensive the shadows will get, which is absolutely not ideal in an infinite builder game. So, and then we have the last option, which is distance field based light shadows. It has some downsides. Our conveyor belts are not shadowed, unlike in this case there is shadows from the conveyor belts. That's why we used a mixed solution for the directional light. And as you can see, some shadow artifacts will pop up, and that's because distance fields are technically a 3D texture of the mesh itself. So if I quickly eject, this is the distance fields for those objects. They look a bit funky, but it's easier for the GPU to calculate it because it's just direct information there. It doesn't really need to do much culling because it's GPU to GPU data that is like 25 to 50% faster, especially with the rendering, the RHA thread that made it even more fast. So yeah, that's why we're using that.
Right. And like, so you mentioned that like conveyor belts aren't using distance field. Is there anything else apart from the conveyor belts?
Yes. Oh yes, I'm not running today. So the limitation is also skeletal meshes. As you can see, just the top part totally disappeared.
Right. And for people that may not know, skeletal meshes are when you have like bone structures to meshes or the models in the game. So like if you want to animate a character, you need to tie in how like you have like a bone structure underneath anything, and then when you render it based on like where that bone is. So when you're like running, the bone will animate where the mesh, like the part of the mesh is essentially. And some of our buildings are animated and some parts of our building are static. So one question that I've been getting is regarding if we are going to implement, so you can turn like lights upside down and stuff like that. Because I believe there's a reason why that isn't working right now or something like that.
The reason is because I forgot to implement something. that's the fair reason. So basically how our lights work, they trace down, so they get the right length. Because the way how I envisioned lights to work is they would be context aware. So they wouldn't just try to go all the way through the world because that would cause a lot of draw calls because of the shadows. So the lights do a line trace with a maximum distance. They should take the maximum distance if they fail to find anything. There are some cases where they don't, and that's something I still have to patch up.
Right. So that's something that might come in the future then.
Yeah.
Okay.
And same with the glass. Currently they block glass because it's a foundation piece, but it should of course ignore glass. But that's totally a future for now.
Is that tricky because you'd need to like separate out the glass portion of the foundation portion and whatnot on those pieces, or?
Oh, I would just if it's a glass, just trace through it, whatever.
Okay.
It's the player's their choice.
Yeah. Who cares? Let's just trace through it. Nobody
Do
will
it.
know. Awesome.
Yes.
Is there anything else that you're planning to do with lights in the future?
No, I think this is kind of it. It would be cool to be able to have like like motion sensory. That would be really dope to have. That's stuff we talked about, but we didn't make or couldn't make. I think it would be really cool that if you enter your factory and the lights turn on, for example, like a sensor gate, like stuff like that would be really cool, or that you can give them inputs, but we'll see. Maybe we get there in the future.
Sounds cool. If you guys think that sounds cool, make sure to go to our QA site, questions.satisfactorygame.com, and upvote that, because I'm pretty sure there's a ticket for that. And make sure to let us know how much you want that. Cool.
And then we here finally have the ceiling light. So we have been cheating, we've been lying. I'm really sorry for that. But those fog planes are not real. There's no real mist going on. They just look like this with a beautiful shader on top of it.
Yeah.
That's it.
To be fair, most lighting in games that have those type of like, they're usually a mesh that you just do that with, so it's not an actual.
Yep. It's really expensive to do volumetrics.
Yeah.
We looked at it and it's just like, maybe in Unreal 5.
You wish.
I wish. So for the lights, we use an implementation that's quite common in games called pooling. So basically what it does, it has a lot of information points of like, okay, here could be a light, there could be a light, there could be a light. And we have an additional background thread for that. Hence, people might have seen some crashes there. But the background thread basically looks where the player is and then gets all those points and okay, these are relevant. So we have a beautiful debug view for that, where we can see all those points. So these lights have one on the top and one on the bottom. And here you can maybe see this one is of class of a light. So there's a spotlight being pulled right here from this buildable. And that way, if I change the amount of lights are allowed, light count, we might put these in the description too, because people can use these commands in the game too. So if you put one light, then it will try to find the most relevant light for the player.
Gotcha. And this explains, for some people have noticed that like if they have a ton of lights and they're running around in the factory, sometimes they can see like turn off in the distance, and that's because of the pooling system that's like telling the game that like there's too many lights going on right now. Okay, not everyone can be on at the same time. Okay. Cool.
That's kind of the problem with it. In theory, you can have as many lights as you want till your engine crashes, because we didn't clamp it yet. So have fun with that.
Yeah, when I was making the trailer, I tried to like, what's the maximum of lights I could try? And then it just absolutely wrecked my computer. I got like 1,000 error messages. That was fun.
So yes, we are also using this for the fog planes. The fog planes are like let's make it daylight. The fog planes are like the shadow planes that are in front of the inputs and outputs, so we can make it look like the items are going properly into the actor instead of just clipping into there. But the problem was like the constructor was an example of really object expensive, because it had 4 fog planes, even though
it was just one.
Those object. It was like 4 objects per constructor. You need to build a lot of constructors to be able to play the game, I guess. So if you have 10 constructors, you have 40 objects that are just those planes. That is so ridiculous. So that's why these are also in the pool system, and it saves a lot of objects for a lot of people. So people should be able to build way more since update 4.
Cool. I believe you also mentioned this in the last video actually you made with Jace, where this was something that we were going to do in the future. And here we are, in the future. The future's now.
Solution.
Cool.
And now I can instantly also show another optimization we did. maybe people didn't notice yet, but they don't have legs anymore.
Yeah.
So what we do with the legs now is we only give them legs when it's relevant. So if they're on the slope, we give them legs. Some buildings still have legs, like the space elevator, obviously, because they are unique to them. They look really good on them too. Without it, it looks a bit weird. The hubs still have them, and what's it called again? The nuclear reactor, I think, still have them. So we have cases where they're still enabled, but in general they are disabled. And also the constructor has 4 legs, but it means it has the leg and the feet. So that would be 8 components for just one constructor.
Right.
Again, so those are where super easy wins, and they also help a lot with loading and saving. Hence, we are going now to the holograms. So the main reason why we changed the holograms, that was because it was just causing a lot of memory issues. It became more apparent with update 4. For some reason, some things changed in the renderer that made it even worse. Also, the conveyor belt items were an offender in that, but we'll get later to that. So instead of swapping the instance mesh as they are now they are instance. All the constructors are one instance now. What we used to do, we used to uninstance the mesh and then make it a hologram, which means every object that was instanced is modified too. For constructors, that might not be the worst, but for walls or foundations, imagine you have 20,000 foundations. It means all those 20,000 foundations are modified because you want to hover on one foundation. So some people on really big saves just had lag spikes modifying their infrastructure.
Right.
Which is not fun. So that was one of the main reasons. The loading part is, for every object that had to be instanced, it had to create its render state, so telling the render thread and the GPU that they should exist. Ironically, the frame after it, they were removed from the GPU, so it had tons and tons of data, and then removed it the frame after it, so the loading time got increased with like 30 to 40%.
So it just did a ton of like unnecessary work at the first frame of the game, and then just threw that kind of away.
Yeah, and that was also a reason for the DX12 instability.
Right.
So that should be improved with that too, I hope. Maybe. TM.
Futures
we
now.
Will see.
Could you just like quickly describe like what instancing means, and like when we talk about that, so that people are aware of what the implication of an instance in a game is when you're rendering stuff?
So an instance is, you have several ways of rendering items, so you can just say like, okay, this isn't rock, just render this one single rock here, which is fine, you render the rock. With instancing, basically you tell like, okay, there are 20 rocks here, and it can do the task 20 times in a sequence, which is really fast because it doesn't need to read the data again. GPUs are really fast, they're really bad at switching tasks.
Right.
So it's really fast to render 20 times the same object in a sequence, knowing it's the same thing, than to render 20 times the same object without knowing it's the same thing in a sequence.
Right. So it essentially batches up the things you want to render to when you're telling the GPU to render them, essentially.
Yeah, and then Unreal has their own implementation on top of that, which is an hierarchy based rendering, which does the best of both worlds. So it has all the instances and it prepares clusters for themselves, which also allow loading and culling and all the optimizations normal instances cannot do. So that's like the best ideal case for instancing. We use it on absolutely everything.
Yeah.
All the walls are done that way, everything except for this little bastard. So yes.
Cool.
So the holograms now use stencils instead of the mesh itself. So if we would show a stencil, go to buff view.
And what is a stencil?
This is a stencil. So we are allowed to write an ID a bit to a separate buffer, and we can read that buffer in post-processing. and based on that buffer we can apply certain effects. So if I would change to 2, 3, 4, 5, here we go, we have different IDs. And if we go back into the game view, there we go, and then we can apply an outline to it with that effect.
Magic.
Or the dismantle effect. So now you can dismantle this rock. Totally not a lie, but this is how we can apply the hologram to this rock, for example.
So essentially what you're doing when you're doing the hologram effect now instead is you're kind of drawing on top of the screen sort of with effect, rather than it being like how everything else is rendered in the game, where it's all like word space and it's...
Yeah.
Yeah.
So technically it's like putting on shades for this specific object.
Right. And I guess the limitation of doing it that way means that you can't have transparency on that object anymore, because you're the frame is already drawn and you're drawing on top of the frame, so it's impossible for you to know like what's behind something that's already been rendered.
That's the problem with it, but the trade-off was so great because accidentally it also improved saving times, which was not the intention, but still a good win. I understand why after the fact, but I didn't think about it when we were doing it. Let's say that way.
You know,
and also one.
We'll take it. You know what? We'll take it. Okay. Like, we'll take any benefit that we can get from anything.
Fair enough. And also one thing that we want to add in the future. We didn't have the UI for it yet, but we want to add your own colored holograms. So if you don't like the red for invalid placement, you can just make it pink, or you can make it orange, whatever you want. And this is also an accessibility feature for people that are colorblind, for example, that see certain colors differently than we see, so they can make it fit for themselves.
Sweet. So there you go, fam. A little bit of a secret thing that's coming in update 5 potentially. Hopefully, fingers crossed.
Most likely.
Being able to do some UX tweaks to it. Cool. All right, should we move on to the next thing?
We're going to the big bus.
The big bus. This one doesn't mess around. It's the big bus.
So this is my beautiful test case for
a
realistic conveyor belt case.
I recognize this.
So let's talk about conveyor belts. With the engine upgrade, we faced the same issue that we got with the loading. The conveyor belts got way more expensive to render. I kind of figured out why, but we cannot change it because it's like in the core of the rendering system of Unreal, which is such a black box to me that it's like, can't touch this. So we decided to find our way around it. Let's disable the average height thread to begin with. And go to the old system of conveyor belt. So this is the old conveyor belt system that's still accessible to everybody. You can see the beautiful colors just turned orange here.
Yeah, I was gonna say, like,
or yellow.
Even on my shitty screen share, when I don't even get like a proper frame rate, I'm like noticing the difference here.
Yep. Also, a lot of items look like they're moving backwards, thanks to the frame rate. But we figured out that updating instances became more expensive, sadly enough. I assume it has to do with GPU bandwidth and threading and all that stuff that got improved, so they had to cut corners elsewhere, I assume. I still didn't fully figure out, but we'll see. So our solution to that is, what if we don't update the instances? So yeah, that was the solution in the end. So what we do instead, we render the positions of the items on a texture, and in the material we read where those items are. So if I can find that subsystem, here we can see how it looks like if it doesn't crash. Please. Okay. So here we see all the items in the scene right now on the texture.
What a weird way to present that. Or look at it.
So technically it's just an array, a 2D array of items. It's a floating texture which is not representable in colors, so that's why it looks super weird. Every row is an item, at least every 3 rows is an item, because the first ID is the lot 0, then lot 1, and then the last lot. And then we store XYZ of this, of course, and the alpha is just there.
Interesting.
And we do the same for the orientation, which is looking even more weird.
Yeah,
because
I can imagine.
this is readable, but it's not because we're using quaternions.
Yeah.
I don't want to go into quaternions because
Nobody wants to.
it's still weird.
Yeah.
They're super weird. It's like, let's represent an orientation with 4 numbers. Yep.
Yeah.
And also they are going from -1 to +1 to make it even more obvious what it is. So yeah, we're using quaternions for that. The reason for that, it's easier to do it in the shader. You can just multiply by quaternion and then you get the right offset. Instead of doing XYZ rotation, then you have to do the right order and yada yada.
Right. Do you get like precision issues being that you render it to a buffer, or does it actually like not really matter?
Surprisingly, I haven't noticed anything yet because it's a 32-bit buffer per channel.
Yeah.
So it's quite memory expensive, but it's cheaper than having okay, just to do a few steps back. We used to have a instance component per unique item per conveyor belt.
Right.
Just let it sink in. So if you would have 5 different items on a long conveyor belt, you have 5 unique components. In the end, that was more of a memory sink than having a big ass texture of 32 bits per channel. That was just cheaper. Like in the end, this is taking 1100 kilobytes to render. So that's pretty cheap.
How does it scale when you have like 10 times as many conveyor belts as you have in this scene versus like, you know, millions of conveyor belts or whatever?
It has a cutoff point. At one point, it just doesn't render the last lot.
Right.
I'm not sure if we can get there. It's pretty far away. Yeah, here. You can see the purple line and the purple fade away. It's really difficult to see, but it's quite far. You can almost not see the items anymore. And there's consideration to make like a far distant version for far distance only, but
right.
if we get there.
Yeah, that's clever.
And the biggest cost of this system is on the CPU right now, which is costing, this scene is costing 1.1 milliseconds to render all these items and update it, because it needs to run on the game thread, sadly enough.
Okay.
It was fully threaded. It was fully working, and then I pushed it out and everybody in the studio was crashing. I was like,
who cares?
But it works on my machine. So one of those classic ones, like with threading, that it works on your own machine and then other people.
Yeah.
Except for only me and Dylan were running it and everybody else was crashing. So I was like, yay.
Well, obviously you and Dylan were doing something much better than everyone else.
Of course.
Obviously.
So yeah, I had to strip it out and have to add that back one day.
Cool.
So yeah, those are the items. They all
nice. Work. So I guess there's still like a couple of I've seen some people say that there's still a couple of parts that haven't moved over to like the new system. If you do find these, make sure to go to our QA site, questions.satisfactorygame.com, and let us know. And that goes for all rendering issues you might face in the game. I remember there being a period where you had being able to pick up items on the belts. Is there anything interesting to share about that? Because you're not actually like, since these aren't actual like physical objects in the world, like how does that work when you're wanting to pick up this particular instance?
We have handle states for that, state handles, I guess they're called. Basically, the old implementation was relying on the instance component that was on there, relying in a way just to check if it existed or not, but that's it. It didn't even use it. So the only fix for that was just saying like, okay, you can always do it.
Okay.
But otherwise, how it works, all the belts are on splines. Let's see, you see the white thin line?
Oh, I wish I had more vertices.
More vert, please. So basically that line represents the belt, So this is 0 and that is 1. And we can calculate from where the player is looking which item to highlight.
Right.
This is getting too much. Slower. There we go. So we just make an approximation from looking at the belt, because if you hover on the item, you're not getting the item either. So it's really based on the belt itself.
Yeah.
Instead.
And I guess
we cannot make thousands of hitboxes for that all the time.
Yeah.
It's just not doable.
And I guess that's the limitation of doing it this way. Is that it's not, like I said, it's not an actual object in the world. It's part of the belt, so to speak.
Yeah, it's abstract data being represented.
Yeah. Cool. So, what's coming in the future when it comes to optimization for Satisfactory? What's planned on your backlog? If there's anything you can talk about that we haven't revealed yet.
Yeah, one of the things I really want to do still is split the world in smaller parts, because a lot of people are like, oh my god, when I cross this line my game lags. It's like, yep, that's because you're loading in 100 megabytes of data and that needs to go to the GPU and the foliage needs to rebuild. So basically what I want to do is to split up the worlds in smaller sections. And this way the stutter should be less or even not apparent. So that would be the ideal case. But we kind of have the workflow issue that the world is in a different branch. Otherwise we have problems with releasing updates, because that means that Hannah and Michiel need to work their ass off so we can release factory content. So that's why that stuff is being slow on our side, I guess.
Right.
The workflow reasons and branching and all the shenanigans.
Cool.
The other thing, I really want to make hierarchy instance splines. But
yeah, that's something we've been talking about since we made splines, I think.
Well, just to break the ice, I got it working, but I don't.
Yeah.
So they work, but they're not worth it at the moment.
Yeah.
So yeah, shit.
Because there was a time when not even like the splines themselves were instanced, and yeah, the performance wasn't great at that point.
Yep, it's much better.
Oh, holy shit.
I guess that sums it up.
All right, thanks Ben for all the insight, and thank you so much for watching. Make sure to like, subscribe, and all that jazz if you thought this was insightful, and hopefully we'll see each other soon enough. So take care, everybody. Bye-bye.
Doei.
Oh, I was like, did I not record? Okay, I did.